First talk today in the afternoon is Stephen Colon, and he's going to talk to us about service virtualization. Thanks so much, Stephen.
Yeah, thank you. Good. All right. Hello, everyone. My name is Stephen Colon. Today we're going to talk about service virtualization, not necessarily just service virtualization itself, but once you actually make the decision, say, hey, we need this in some capacity. Maybe you listened to the talk earlier where our performance engineer mentioned, oh, mocking and virtualization at some point. You may look into that. You may find it may be useful. But how do you get from just knowing it's useful theoretically to actually making some use of it, getting a proper tool, getting actual best practices around it, and then actually measuring what that impact can be of virtualization just on your whole process, on your whole SDLC, if you will. So I am from SmartBear, and I'm not going to spend too much time talking about SmartBear, but just a little information about us. We are a software vendor of software quality tools around the SDLC. I'm actually based in Boston, Massachusetts, so it's great to come visit a city that seems to be sponsored by Starbucks, because I come from the city that's sponsored by Dunkin' Donuts. So I feel very at home, even though it seems like it's a competitor space. And yeah, we have a pretty huge footprint worldwide, really working with a lot of different customers around a lot of different tools around front end, back end. Primarily my role focuses on web services and APIs, which is where my knowledge of service virtualization comes from, stemming from our tool, Service V Pro, but then also talking to so many different customers about what they're going to use it for. Either they're small companies, large companies that may be new sort of web tech companies, or really older companies that just kind of going through this digital transformation. So these are just all of our tools here that we offer. And so we're going to focus today on virtualization. I'm going to go over a couple of these things here, why you want to virtualize, and then going into how do you start choosing a suitable tool. There's a lot of things out there coming from open source to commercial. How you sort of look at that space, seeing what is the best fit for you, is very critical to see how best can you use this. And then going into some best practices and then measuring this impact of service virtualization and how you can then say, we did this 6 months ago, a year ago, did it actually have an impact? And we actually have a little bit of a case study around that provided by SmartBear, so we can talk to that a little bit more just in terms of virtualization. So with that in mind, one thing we always like to differentiate is the difference between mocking and virtualization. Now, the thing that I'm striving for in this talk is really virtualization. It's a bit more complex in this sort of way we draw between mocking and virtualization. It's really mocking being a single call and response, nothing too complex. It serves its purpose for a quick, call and response, but virtualization is taking systems that can be a lot more complex and mimicking them in some way, virtualizing them, so that you have control of them. This can be a system that is going to be implemented. This could be a system that already exists today, maybe from another team, another vendor. So that's what we're going to really look at, is virtualization itself, even though they get used sort of as the same sort of concept, but I like to draw this difference very quickly. So virtualization, and why would you virtualize? Now, for everyone here in the room, do you guys virtualize today just by a show of hands in any sort of way? Okay, we got a couple of hands. That's great. Yeah. So, there may be one reason or another, and it may depend on the project, but virtualization is something that I sort of, took these 3 points for. Parallel testing and development during an API's implementation. That's what this graphic shows off here. If you're planning a new web service or a new service of any kind, at some point, you may follow a design-first approach. You design your API, and at some point, it'll go into implementation. What happens during that implementation? Does every other team sit there? Does every other team just go in and work on something else? You can actually use virtualization to enable your testing teams and your front-end development teams to utilize a virtualized version of this asset, a prototype, if you will, and then do the work around that prototype, around that API. The front-end developers can develop their front-end. The testers can start developing their testing workflows that may be specific to that service. And then by the time the API is released, you have all of this work done around it. You then, take your UI, take your tests, start executing it against the real service, and really you're just saving a lot of time. Where a lot of the work is done already, you just go in and now you have it ready. By the time you are looking to release, you may have pushed that timeline forward a bit now that you have all of this work done in parallel. The other reason, really, virtualization is a form of controlling these dependencies, whether it's during continuous testing or continuous development, there can be some issue with this dependency. So at a very high level, I like to define it as you would want to virtualize if you have a dependency that is causing a bottleneck in your workflow. That is just very broad, but essentially, if it's something like testing, you may not have a dependency from a vendor with performance testing capabilities. A gentleman earlier mentioned, I have a service and it doesn't have its auto-scaling capability. How do I now test against it? This is where virtualization will come into play, where you can virtualize it, get control of it, apply whatever you need to it, and then just use it as you need to, without having to contact this vendor, without having to ask them to change anything. For development, it would be the similar thing, but ensuring code quality would be more important there. You're building an integration into a very complex system. Something goes wrong, how do you know it's your code or this dependency that may have changed in some way? Virtualize that dependency so that you know exactly what it is. It has not changed, it will not change because you have control of it, and then go ahead and continue your development with that focus. And then just providing a separated sandbox. This can be useful for many different things. In the case study I'm going to talk to at the very end of this, there's really, if you need a sandbox to train people on your service, for example, you may not want them using your production API for whatever reason. Provide a sandbox for them have this unlimited usage of it without having to worry about, am I adding all of this extra load to my service unintentionally? So these are a couple of the reasons. Now, you guys may have more reasons, and as we are sort of going through today, I would be happy to sort of hear some more reasons that you guys may have come across. But these are some of the big ones that I've really seen in the different companies I've spoken to. So at this point, we're going to talk about selecting a suitable tool. For one or more reasons, you're here, you want to virtualize. What do you do after you sort of realize that? And that's where selecting a suitable tool will come into play, especially since you don't want to reinvent the wheel. You don't want to virtualize as sort of your job. A lot of times it's in addition to something. So trying to make that as easy as possible is going to be the key here. So why does this matter? As I said, really just that focus on what tools you need. And these are some criteria that I sort of bring up as I've seen happen just as I have these conversations with multiple different people. The first thing is understanding what protocols do you need to virtualize. Is it just web services like REST or SOAP? Is it a mainframe that uses TCP? Or are you looking for something like environment management for your tests, so you're going to virtualize something like a database? Understanding the scope of your project that you're going to need virtualization for is something that's going to come up again and again in this talk, because it's really critical when you go into virtualization. The next point is really the technical skill of your teams. This isn't about, can they write a script or not? This is more about, in a certain period of time, are they going to be able to take that time out to write a script to do something like virtualizing? A lot of times, you will say, yeah, they can do that, but we'd rather spend that time elsewhere. So in this case, it may not be more about technical skill, more just about the time. But it is a consideration that you have to give. If you give someone a tool and say, hey, this is a tool where you need to script out all of these virtualizations and I need all of this done by next week, if they take 5 days to even just learn how to use the tool, it really becomes an effort that's wasted. So this becomes pretty critical as you look at your tool analysis. Third one, I dumbed it down to a single word, and that's budget. Something that no one likes to really think about, but is always there. How much money do you have for this? Because a lot of times this is in addition to something. So you may not have the highest budget. You may not be able to afford necessarily the most expensive tooling, and you may not need to. So it is a consideration. And then how frequently do you expect to need to virtualize? A lot of times, it's a digital transformation. People are looking to embed this into their multiple systems of development and, different applications, and it'll be a lot more frequently. They need a large-scale sort of rollout plan for multiple teams. A lot of times, it may just be a single project. Okay, we want to use it for this single project. If it works, we may roll it out further, but this is the scope that we're looking at. And then really, the tools that you're going to use alongside virtualization also becomes very critical. If you're designing something like a web service, if you're using something like OpenAPI, you may want a virtualization tool that is able to consume OpenAPI, because that'll really help you if you're building a prototype to just consume the OpenAPI specification that defines your service quickly, so you can build a prototype just off the ground a lot quicker. Any CI/CD tools, application, sort of their relevant code bases, I sort of added that there as a consideration. A lot of the tools I talk about, I actually prefer virtualization tools that are agnostic to a single code base, sort of language, just because I don't think that's a limitation that you really need a lot of the time. I don't think you need a tool that's written specifically in Java to perform virtualization effectively. But it is a consideration, just kind of the ecosystem that you're looking to virtualize in. So this is some of the criteria, and at this point, I kind of like to open up and be a little bit more flexible. Any questions on any of these, sort of looking at these criteria, anything that you may want me to sort of elaborate on? I kind of like to, I know we can do questions at the end, but I like to sort of break it up in that way. Great. So let's go ahead and just look at some tool examples. And I have a couple here. Now, I am from SmartBear, so Service vPro is there. It is there because I am more familiar with it. So when I sort of started this journey and sort of coming up with this talk and presentation, that was really the starting off point that I sort of had the most experience. And then I sort of broke out and looked at the other tools in the same space. And I really broke it down into sort of open source and commercial, because there are some implications with each. So for open source, a lot of times, sort of in the classic sense, it's a community that comes together, builds this tool out for a specific need. It may or may not have some companies supporting it. So a lot of times it depends on how far do you want to go in using this open source tool. You may have to configure a lot more things than you would like. So in this case, we're going to look at two tools, Mountebank, which is an open source framework, and Hoverfly, which is, again, open source, but the difference with Hoverfly is that it does have a company on top of it that's sort of building an offering on top of it. And we'll kind of look at those two as the differences in the open source players in the space, just kind of two sort of cornerstones. And then for the commercial side, we're going to look at Service vPro and then CA Broadcom's Service Virtualization, and look at those two in opposition to each other. Both, companies that have pretty good reputations, but the tooling is modeled in different ways, being more sort of CA with a more centralized platforming system that they create, while Service vPro offers more of a lightweight sort of distributed way to virtualize that doesn't need a single centralized team to do so. So we're going to dig into these tools a bit more, and it's going to be fairly subjective. I'm going to say, this is a pro, this is a con. You may look at it and say, that doesn't seem like it to me. That's pretty much because pros and cons are inherently subjective. But it will be a part of just looking at these tools and how we sort of analyze what can fit our needs. So the first tool is Mountebank, and this is I'm not sure exactly how many people use this tool, but it is a tool I've come into contact with a couple of times. It's a self-contained server-based solution that utilizes contracts that you send to the server to define services. It supports multiple protocols, as we see here. And on the side, we're going to see a little bit of a snippet, either the UI of the tool, or if it's an open source tool that works on contracts like this, we'll see an example of the contract. And, this is a tool that is lightweight, but doesn't have a lot of the sort of frills attached to it when it comes to virtualization. So some of the things that I think are make it very hard to use is the lack of its recording functionality. A lot of times, if you're virtualizing a system, a dependency that already exists, if you can record at least a part of that system and use that to really sort of kickstart your effort and configure your virtualization from there, you save a lot of time. So not having that seemed like a pretty big negative to me. No native integrations with CI/CD. It's lightweight enough that anyone sort of, any sort of part of the DevOps space, any tools can make an integration, but there is no native support available. And overall, I found it kind of hard to learn. Just kind of looking at how they define this contract seems a bit less intuitive, but that's something that's subjective. You may look at this and say, no, this makes sense, and I can bang out a couple of different virtual services quickly. More power to you. So one of the good things is it did have the ability to define custom protocols. So if you're not following a protocol that may be listed here, if you're a larger organization and you have some custom protocol, it does have a mechanism to create a virtual service that plugs into your network, into your own protocol. I didn't have too much time to dig into this from a technical perspective. I didn't have access to a custom protocol per se, but it is something that I thought was unique that wasn't really offered in a lot of other tools. So that is interesting. That is something that I think will differentiate it when you have a protocol that may not be following anything else. The next tool is Hoverfly. This is the second open source tool. Hoverfly is an open source tool, I like to say enhanced by Specto Labs. You can get this tool, use it on its own, but Specto Labs does have an offering on top of that. It's a similar self-contained server-based solution. One interesting thing, it does have native Python and Java bindings. So it does work on a similar sort of contract system. The way the contracts are written seems a bit more friendly in terms of just reading it, looking at pairs, requests, and sort of breaking down from there what each request will do. Seemed a lot more intuitive, but I didn't necessarily have to write the contract from scratch. One of the pros is that it actually has the ability to capture API traffic, to create these simulations, as they call it. So I actually learned how to write and modify these, starting off by just recording the service that I'm looking to virtualize. So it saved me a lot of time when I needed to do that first initial step, which is just understand the tool, get some information down, and then I can go in and configure it further for whatever that need may be. But really that recording played a pretty strong role. It also works as a web server or a proxy server, so it doesn't actually even have to record or host these virtual services. It can actually modify requests in flight to an actual service. And that was interesting in terms of just expanding its capability in terms of how it can be used, not necessarily just for virtualization, but just in general if you're doing anything around it. It has a CLI, Docker, Kubernetes support, which is always nice. If you need to use any of these systems around virtualization, you have that support natively. And Specto Labs does have a cloud hosting solution. It's open source, meaning you can just get it on your computer today, run it on your command line, or you can use Specto Labs to take these virtual services, these contracts, put it up in their cloud, and then have your team have access to it. It does go up a couple of different levels depending on the amount of access you need, how many simulations or API calls per second you're performing. And some of the cons, limited protocols. It's focused only on HTTP web services, really. And it didn't really seem to have a sort of on-prem enterprise-grade solution within the Specto Labs offering. So it was something that did bridge the gap, did have support for if you're trying to use virtualization a lot more. But at some point, it did seem like its highest level would only have something like 200 requests per second for a call, which if you're performance testing, you can easily blow out of the water. So that's sort of where I saw it fall short. But in terms of an open source tool, I think this is one of the big players in that space, where if you're looking just for virtualization and starting with the cheapest option first, this is always a good thing to look at. So now we're going to shift over to the commercial space. CA Technologies, recently acquired by Broadcom, is a codeless virtualization solution. It's offered within their platform with their testing tools, and it does have a wide-ranging support for different services. So web services that we've seen, mainframe, ESP, financial, really a lot of these different protocols that aren't common things within virtualization, especially those financial sort of protocols, they have native support for. Now, that's one great thing, having support for those industry-specific standards. It makes it really powerful. There may be just the only tool out there that supports it, so this may be where you go. It has that recording functionality, which again saves a lot of time, and it does have integrations to make it pretty flexible with a REST API or CLI. And it is an enterprise-grade solution, meaning you get sort of the services provided by CA, you get things, assistance and training and things like that, which can be really helpful, especially if you're a financial institution and you're trying to roll out virtualization. But it does follow sort of an older model of applications. It's more of a monolith, which isn't necessarily conducive if you're trying to do a digital transformation into something like Agile or something that's like Agile. And it's focused heavily on consultant services to deploy this tool, which a lot of companies I speak to who already have this see that as a negative. It adds a lot of overhead to the just blowing out the budget that you thought you had for virtualization. And a lot of times, one of the clients I've spoken to say, it has all the support for all these web services, which is great, it's powerful, but the UI is so difficult I can't even get to actually performing these virtualizations, so they might as well not exist at all. So that's another aspect that I think is a negative in terms of CA Broadcom's offering. And they are shifting to more of a community edition to this, where they're trying to streamline this UI and these protocols that they support to be a lot more friendly to that system. So this is a commercial tool, a lot more heavyweight in terms of how it was made. And then Service V Pro is similar in the sense of it's a codeless virtualization solution. It has a deployment solution into Virt Server, which is a hub of these virtual services. So this is all on-premise. You can have this within your system, hosted within your own sort of cloud system, wherever that may be. Supports multiple protocols. Not as expansive as CA, if you would see there. But a lot of times, some of the pros is the UI and the deployment process is very easy to use based within its application. It's lightweight, meaning you can get it into a lot more people's hands when you try to distribute virtualization amongst multiple teams. So you can do that a lot easier. The recording configure functionality, again, I think is pretty crucial. And then support for CLI, Maven, Jenkins, Docker. And it is an enterprise-grade solution. So it follows a different sort of mindset, trying to be a lot more lightweight, get it into the relevant people's hands, and letting virtualization be a simple process, not something that you have to spend all your time on, get a central team focused on this specifically. But one thing it does lack is those industry-specific protocols. So if you're in something like the financial institution that needs this specific finance protocol, you may not even have the choice to go into something different. You may have to stick with a tool that does provide that. So those are the different tools, kind of looking at, there's a lot more tools out there than this, but just kind of looking at the different sets there. Great question. So I use the word codeless, but obviously, oh yes, that's a good point. The question was, what is a codeless virtualization solution? I define this as, because obviously there's a code base, this is an application, but I define it as to perform virtualization, you do not need to write code as that first act. There is sort of, you can script on top of these virtualizations, but it's all based in the UI, configuring things like request and response. It's not having to learn, Java, Python to perform these, or specific contracts like the open source tools did. So that's kind of how I define it there. Does that make sense? Okay, great. So that will be more towards, even if someone's really technical, if you don't want to sort of give them all of this time to have to learn this tool that requires all these contracts and scripting, then you would use something like those commercial tools. But and then you have to consider, what is my budget then at that point? Because it will be more expensive. So it's kind of this balancing act between these different criteria and what's more important to have your teams virtualized in the most efficient way possible. So with that in mind, going through these different tools, I do like to talk about just best practices. You have this criteria, you select a tool that you think matches this in the best way possible. Now, what should you start looking towards enabling to make sure you use this as effectively as possible? The first thing is, don't virtualize everything. Raise your hand if you like doing more work than you have to. That is no one. When you virtualize, do not virtualize everything. Be effective with your time. Virtualization is not a job in its own. It's something you add to processes to enhance them, to gain more control over dependencies. Understand your exact need, those criteria, the tool you chose, and then use that as a guide to knowing what services actually need to be virtualized. And I'll talk about this a little bit more. The second part is making it a part of your process. It can be a culture shift to virtualize. It's sort of encapsulated into this shift left movement, if you will, if I want to put a name to it. So you need to provide easy ways for it to be utilized and integrated into existing workflows, because a lot of the times I work with companies that they realize they need virtualization, they get the tool they think that works really well, but they don't use it for 8 months because they don't know how to start integrating it, teams don't know how to start adopting it. So making that very clear at the beginning becomes very crucial. And not everyone needs to virtualize, so you can establish a deployment process for these virtualizations that you need. You can have certain members of certain teams doing this. Not everyone needs to do this, so that's something that also needs to be made very clear as well. And then this is a little bit self-referential to the agenda, but just understanding the need to measure the impact. What is the driver for this initiative? So that you can set clear goals based on that, and then gather reports on those milestones periodically. Now, this is very broad, and we'll talk about a specific use case here, but this is something that's been coming up again and again in different talks. Just analytics, reporting, just understanding what's going on, and if you virtualize, making sure that the overhead you've added benefits in terms of the time you save, the defects you catch, a lot earlier. Because if it's not, then you may have chosen an incorrect tool. You may have a team that may not understand how to use this most effectively. There may be something there that you need to modify. So don't virtualize everything. Don't work more than you have to, that's my mantra really. And in this case, most services, they're intertwined, they're layered with each other in some way. So understanding what you need to virtualize in a project is really about saying, okay, which layer do I need to virtualize? How many things do I need to virtualize so I can get to my end goal a lot quicker? So we have an example here of a multi-layered infrastructure. I use infrastructure lightly. It's just a bunch of layers and letters. And at the top, there's that front-end application. Now, in this case, I'm just virtualizing the top layer. Why am I doing that? I'm focusing on front end of the application. I'm isolating the service and the front-end development so that I can test, can my front-end application handle malformed data from my service? So I don't care what's in those other layers. That's not what I'm looking at. I'm looking at that top layer, that top interaction, and seeing if my front-end can handle if at any point something malformed came back. So I'm saving a lot of time. I'm not virtualizing every single layer when I'm just focusing on my front end and testing it for the resilience, if you will, when it comes to your front end connecting to your data. Going a little bit deeper into another example, maybe you want to go a little deeper into a lower layer in your application. So you're focused more on the back end. You want to control the service that is being integrated against. So you take some layer. This may be a third-party dependency, whatever that may be. And you want to test if the service can be handled, if it's deprecated, or if you add some experimental functionality to this specific layer, to that specific service in that layer, rather, to see if it breaks anything else, see what that impact may be. You may want to support load testing efforts without destabilizing your whole environment or destabilizing your vendor's environment, which can lead to angry phone calls and things like that. So you will virtualize something sort of more lower level, focused on back-end testing primarily. So this is just quick examples, really sort of an exercise in thinking about what can I virtualize for my specific purpose. You may have to do multiple of them, but a lot of times you don't have to do all of them. That's almost never the case. If you understand your purpose, you can understand what you need to virtualize. And then making virtualization as a part of your process. It should be used by multiple teams to really increase its impact. And this depends on a case-by-case basis. A couple examples here. If you're architecting your APIs first, designing your APIs first, give virtualization to your architect teams so they can create virtual prototypes of these services. They can, get feedback based on these prototypes. They can hand this off to front-end devs, testers, before the API is fully implemented. Developers, virtualizing their dependencies to ensure code quality, sort of siloing off their code from the fact that a dependency may be the issue, so that when it comes time to deployment and testing, it's not going to be a sort of finger-pointing sort of game where everyone thinks their dependency is the thing that broke the system. It's, no, I tested this in a very isolated way, so I know if my code is fine or not because the dependencies are. And then if you automate, or the third example is the QA team, again, isolating their application by making sure they're testing only the application, not a faulty dependency, which may not be the focus, it may not be what they're looking at the moment. If you automate anything, development or testing, you should bring virtualization along. It's something you add in addition to processes. If you virtualize something for testing, let's say performance testing your application, and you virtualize a couple of those dependencies in your layers, have a system to automatically start those before you automatically load test. If you're sort of within a pipeline like Jenkins, making sure that you reduce the manual effort as you're continuously using virtualization becomes a key part of this, so that it's a lot easier to use, a lot easier to bring in. And then any tools should be easy to use and readily available. That's kind of broad, and I left that like that on purpose because that can mean different things depending on your company. So looking at that and what that means really depends on how you look at those criteria, those tools, to see, okay, is this something we can use effectively? And that's an easy way to make it a part of your process. So the last part is really measuring impact. I put it as the last best practice, but it's also the last sort of thing within the agenda as well. And these are pretty vague, and the reason is this is, again, also very dependent on what you guys are looking to do around virtualization in terms of the specific use case that may become what kind of metrics you can already gather, what kind of metrics you're looking to gather. A lot of times, these are sort of 4 of the big ones that I've seen come up time and time again. Increasing the amount of cross-team collaboration can be a huge impact of virtualization. If you have architect teams now able to communicate with developers more seamlessly because they can just provide prototypes of their services as opposed to having to just sort of have this sort of communication and hope developers implement what the architects thought they were sort of suggesting, can be crucial, right? Cross-team collaboration, increasing that. Catching defects a lot earlier within the SDLC becomes critical as well, where you have these prototypes very early. If something isn't correct, or if you isolate your application and its dependencies from it, and something's wrong with the application, you can see that a lot quicker, as opposed to seeing that a lot later down the line, trying to sort of fish out where this issue may be. The time to release new services is something that also increases pretty heavily when you virtualize. Just incorporating these systems where teams aren't sitting down as much waiting for other teams to do work. You get your QA team creating their testing workflows. You get your front-end team modifying their application for this new service that's coming out. And then by the time the service is implemented, you have all of this work around it already done. And this time to release is something that you should measure before virtualization, after virtualization to see. And then overall improvement to agile, I'm gonna say agile type processes is also a key here. And I left that pretty vague because that can, again, mean a lot of different things to a lot of different people. And in one of the examples, we're gonna see exactly what it means to a specific company. But these are the measurements of impact. And just to really end this off, I kind of like to include a case study because I mentioned a lot of things. This may or may not have been helpful or news to anyone. But looking at a case study, looking at what exactly sort of a company saw as a benefit can be pretty crucial. So we worked with a company, Zurich Insurance Group, not a development company, but they were going through a digital transformation. In their case, they were looking at providing operations with a training environment that performs consistently, building out environments that match their production and testing environments seamlessly, and really just streamlining the process of testing these API connections between their internal and external systems. So they chose a tool like Service V Pro, where their measured impact included things like saving nearly $500,000 on the cost of building this training environment when they just virtualized from recording their existing system. It helped keep the training environment up a lot longer than they initially expected, than they initially had, so they didn't have to worry about this as often. And it really reduced the time and resource costs in identifying and fixing applications when they had these dependencies that were isolated during their testing. And there's a couple other points here, but it also enabled their training environment for consistent performance. Really, that sandbox, just having that there without having to worry about, hey, your dependency changed yesterday. Now your sandbox, all of these systems don't work as well as they did before. They kind of rolled out a more consistent strategy to their training. So this is just a case study here, an example, but there are many examples. There are many different sort of use cases around this. So thank you all for listening. I hope this was helpful, just kind of understanding, okay, I'm looking to virtualize. How do I start picking things out like tools and measurements to start looking at its impact and some best practices around it? If you'd like this PowerPoint, feel free to contact me, either the DevOpsDays Slack, the email, LinkedIn. I'm accessible in all of those. I can send this out as well. As a last note, thank you to the organizers as well. This has been a great session and a great, not session, I'm talking about myself, a great conference that has a great community. So I really appreciate being here. Thank you.
Let's see.
I assume you're going to ask.
Yeah,
we
I
have
gave
questions.
you this, I think, and that was dumb. Okay. We have some time for some questions, if anybody has one. Yep.
She'll pass her on the cube.
It doesn't, yeah, it's on now.
Oh, it's on now.
Hey, thanks for the talk, first of all. I found it very interesting. So I was wondering, I feel like we have a lot of challenges with virtualization for services because of the fact that the same data is required between a lot of services for the dependent applications to function properly.
Yeah.
What are some ways that you could approach managing that complexity?
That's a great question. So a lot of times you can just remove said complexity. I think virtualization, when you try to think about complexity, do you need it? If you're doing something like testing, why do you even have something like that? So a virtualization solution that includes databases can be very useful, where you incorporate not only web services, but the data that you're testing against it. Just take it out. Why does it have to be an issue? So that's where I think virtualization can really help, sort of not only looking at services, but looking at the data, the test management data that you need there as well.
Okay, do we have any? Yes, one more question.
There's lights there.
Do you have any guidance around endpoint security relative to like OpenID or OAuth, and how to include that in your mocking framework or your virtualization framework?
That's a good question. I think that's something that isn't addressed enough in virtualization, if I'm going to be quite honest. Virtualization is something that kind of hasn't thought about security, and if I were to be frank. A lot of times we look at testing, we look at development. We're not looking at the security of aspects. A lot of these tools don't really have the capability for virtualizing security per se. So unfortunately, I don't have a good answer to that. But that is something that I think if virtualization, if its tool starts looking at that a lot further, then virtualization can start moving into the security compliance space, not only sort of the spaces that we were talking to.
Okay, we have time for maybe one more question, if there is one. Okay, otherwise, let's give Stephen a round of applause. Thank you so much.
Thank you.